Today we're going to start with chemistry. Sorry, are you hearing a background sound?
No.
Okay, better. Now, we're going to start off with chemistry on electrolysis. Um, electrolysis. Have you done redox reaction?
Yes.
Okay, so you understand the concept of redox reaction, right?
Yes.
Okay, that's the basis. That's understanding redox reaction. Will give us an insight into understanding. Give us an insight into understanding electrolysis. But first and foremost, let's understand the concept of electrolysis. Okay, I'm going to be defining some terms, so I'll need you to write because the things we'll be defining would help us to understand what the things we'll be defining, the concepts we'll be laying. Today will be more of laying a foundation to electrolysis, then subsequently we'll be building from such foundations on electrolysis. Okay, let's start with the definition of electrolysis. What do you understand by electrolysis? Because this has been a confusing topic for most students. But I bet you understanding redox reaction gives you an edge for electrolysis. Now, what do you understand by electrolysis? What have you heard about electrolysis? Can you share with me?
Um, is the decomposition of electrolytes by the process of electricity through electrode.
Sorry, I didn't hear that. Could you be audible, please?
Electrolysis is the decomposition of electrolytes by the process of electricity through heating, either its molten or solution state.
Wait, oh no.
Either in its molten or solution state.
Sorry, I didn't get that, please. Sorry, who is disturbing you there now?
It's the chemical.
Sorry, could you repeat that? I didn't hear that.
The chemical decomposition of electrolytes by the passage of electricity through either in its molten or solution state.
Okay, now let's write that down. Electrolysis is a chemical decomposition of a compound. Electrolysis, the chemical decomposition of a compound brought by direct currents passing through either a solution of the compound. That electrolysis is a chemical decomposition of a compound brought by direct currents passing through either a solution of the compound or the molten compound. Okay, did you get that, please?
Yes.
Now, what we're trying to say is this. Since electrolysis has to do with chemical decomposition, that suggests to us that solids cannot be electrolyzed. I'm going to repeat that again, that since we are talking about chemical decomposition, that suggests to us that solids cannot be electrolyzed. Why?
because it cannot conduct electricity
So what?
because electricity cannot pass through solids.
Okay. Electricity cannot pass through them. I okay. Not a coherent. If I was to take you on that word, that means you tell me why metals are solid conduct electricity also. If I was to take you on that, you would explain to me why. Okay, metals. Why would they conduct electricity? Number one, they are solids. So, nevertheless, um, when we're talking about electrolysis, we're trying to talk about that why solids cannot conduct electricity is because their molecules are, there are ions between them. There are not free spaces in between um, their ions. So because of that, they would not be able, or most of them would not be able to really conduct electricity. Please just give me a few minutes. I'm trying to get something. All right. Now we said electrolysis is actually is whereby the composition occurs when an electric current is passed through an electrolyte. Now let's define some concepts. Number one, electrode, because we'll be using this a whole lot. We'll be talking about electrode. Remember, when we talk about acids, acid is, we're talking about they can be decomposed, but especially when they're in water. Solids, I say, cannot conduct electricity because they cannot be ionized. So one of the conditions for electrolysis is it must be, number one, be in molten form. That means when we talk about molten form, please, get this thing I'm writing. Please, I'll need you to write them down. I mean, get this thing I'm saying. I need you to probably write them down. One of the conditions for electrolysis, if you were asked, um, state the electrolysis of solid sodium chloride, what they're just trying to test is if you have the knowledge that solids cannot be electrolyzed, that means they cannot be ionized because their ions are held together. The intermolecular forces of attraction between their molecules are strong. So because of that, they cannot be electrolyzed, they cannot be ionized. Why? Except they are in molten form. So the conditions of electrolysis is, number one, it has to be in molten form, and number two, it has to be in solution, in an aqueous form. That means with water. Now, if you're talking about molten form, that's melted form, number one, and number two, it has to be in solution. Now it could be an aqueous solution. Okay. Now let's look at some terminologies that we are going to be defining. Number one, electrodes. Now, what are electrodes? Please write this. Electrodes are conductors in form of wires. Electrode. Electrodes are conductors in form of wires, rods or plates through which an electric current enters. Electrodes are conductors in form of wires, rods, or plates through which an electric current enters or leaves the electrolyte. Now, another way we could define electrolyte is this is a compound which conducts electricity and is decomposed in the process. This is a compound which conducts electricity and is decomposed in the process. Sorry, did I say that? Sorry. Sorry, please don't write that. Sorry, that was a mistake. I just gave you the definition. The First one I gave you that these are conductors in form of wires. That's electrode. But the other one I gave you, this is a compound that conducts electricity. That is electrolyte. Please correct that. The first one I gave you, which is these are conductors in form of wires, rods through which an electric current leaves or enters the electrolyte. That is an electrode. That's an electrode. And the other one I gave you that I said this is a compound which conducts electricity and is decomposed in the process, that is called electrolyte. Did you get that, please?
Yeah.
Okay. Now, I have just given you definition for electrolytes. Okay, but I want us to note something in electrode. There's something I want you to note there. Just write NB note for electrode. For electrode. In an electrolytic cell, these questions come out mostly in WAEC. In an electrolytic cell, the negative electrode is known as the cathode. In an electrolytic cell, the negative electrode is known as the cathode, while the positive electrode is known as the anode. Okay, now that's for electrolytic cell, but definitely we have electrochemical cell. Now, electrolytic cell has to do with strictly electricity. Now, electrochemical cell has to do with electricity with chemicals. Now, in an electrochemical cell, the reverse is the case. That means in an electrochemical cell, the negative electrode is the anode, while the positive electrode is the cathode. In an electrochemical cell, the negative electrode is the anode, while the positive electrode is the cathode. So please, let's be aware of that. Electrolytic cell, now we will be considering majorly electrolytic cell before we move forward to electrochemical cell. So electrolytic cell, the negative electrode, we know it as the cathode, while the positive electrode is known as the anode. Now, I already given you the definition for electrolyte that I said is a compound. Now, it's a compound that conducts electricity. It could be in a molten form, remember? It could be in aqueous form, and it conducts electricity and is also decomposed in the process. Now, electrolytes most times conduct electric currents by movement of ions. Now, examples of electrolytes, we have them as sodium chloride, copper 2 chloride, copper tetraoxosulfate 6, hydrogen chloride, and hydrogen tetraoxosulfate 6. You'll be seeing more of these compounds when we delve further into electrolysis. Now, please get this, electrolytes may be weak or strong. That means we have weak electrolytes and strong electrolytes. So let's talk about the strong electrolytes. Weak electrolytes and strong electrolytes. Remember, we said if electrolytes are compounds, they conduct electricity, and yet they are also decomposed in the process. Now, with this, let's look at the strong electrolytes. What makes it strong? Remember when we considered acid, we talked about strong acids and we talked about weak acids. What makes an acid strong? Or what makes an acid to be classified as strong acid? And what makes an acid to be classified as weak acid? Can you answer that, please? Can you remember?
Um, and acid is strong.
Sorry, I didn't get that. What did you say?
It's strong. And acid is strong when the
Okay, okay, okay. Maybe you need to understand when we say an acid is strong. Remember, one of the definitions I gave you for acid is that an acid is a substance that produces hydrogen ion as the only positive ion when dissolved in water. Okay. Now, what makes an acid strong is that it ionizes completely in water. And weak acid, it does not ionize properly, it ionizes partially in water. Now, the same thing for electrolytes. Strong electrolytes, what makes it strong? Strong electrolytes ionize completely. Strong electrolytes, they ionize completely and can conduct large electric currents. They can conduct large electric currents since they are composed entirely of free moving ions. Now, remember what I said. Number one, they ionize completely. Number two, they can conduct large electric currents. Why? They have free moving ions. One of the things that can be used as examples of strong electrolyte, number one, majorly are strong acids and strong bases or salts, strong salts. Now, for you to have a strong electrolyte, when we considered acid, base, and salt, we made mention of strong acids, strong bases. Now, what would make an electrolyte to be strong, meaning that it can ionize completely, conduct large electric currents, is because they are composed of free moving electrons, and the examples are strong acid and strong bases. So weak electrolytes are partially ionized. They are partially ionized and they conduct electricity very poor, or they conduct electricity poorly because they contain low concentration of ions. They ionize partially and conduct electricity poorly because they contain low concentration of ions. Examples include the weak acid and the weak base. Okay, we're going to be talking about non-electrolytes. Non-electrolytes. Now, non-electrolytes, they do not conduct electricity since they do not ionize. They do not conduct electricity since they do not ionize. An example of such is ethane, benzene, cane sugar. And if you notice, most of these compounds I'm calling, these are organic compounds. Benzene is an organic compound, ethane is organic compound, trichloromethane, so have you done organic chemistry?
no,
Okay. Sorry, when I mean organic compound, that means they are hydrocarbons. And what are hydrocarbons? Hydrocarbons are compounds that contain just carbon and hydrogen atoms only. That's that's a word of its own, another topic. Now, let's look at the next one, electrolytic cell. Electrolytic cell. Now, electrolytic cell is an assembly of two electrodes. Remember, we said, okay, please write this down before I explain that. Electrolytic cell is an assembly of two electrodes in an electrolyte and is used for electrolysis of a substance. Electrolytic cell, this is an assembly of electrodes. An assembly of electrodes. Remember, we said the electrodes are conductors of electricity, meaning that, coming. Okay, I said electrolytic cell is an example of two electrodes. And electrodes, what are they? They are conductors in form of wires through which electricity can enter or leave the electrolyte. Now, electrolytic cell is an assembly of two electrodes in an electrolyte. Remember, an electrolyte can conduct electricity, and yet they are decomposed in the process. And this can be used for electrolysis. Now, I believe when you tried to check your notes, you saw, come in, let me see if I could get a very big diagram for you. Okay. I believe okay. Um, okay, okay. I believe you saw, when you were going through your notes, you saw something like this. Please, can you see my screen?
Yes.
Okay. Now, I'm going to be using this to
Yes.
explain something here. All right. Now, look at this. This is a cell. Now, two cells make a battery. So this is a battery. Now, we have one cell and the other cell here. Now, this is the battery. Now, we have the negative electrode. What's the negative electrode I said again? What's it called in an electrolytic cell? Ooh. Are you there? Can you hear me? Sorry, what's the negative electrode I said again?
Cathode.
Sorry?
Cathode.
Cathode, correct. The negative, this is the negative. And what is what's the positive electrode?
Anode.
Now, look at this. This negative shows that this is the cathode and this is the anode. Now, look at where current flows. Now, current flows from the anode, and then goes, that's the current flows from here. Look at the direction of the current from the anode here. And because I'm going to explain something very important here, this is the negative electrode and this is the positive electrode. Because this is the negative electrode, what kind of ions do you think it will attract?
Positive and
Yeah, positive ions. Why? Because the law of electricity, the negative, like ions, or the law of magnetism, like we know, the like poles, they repel and your like poles attract. So definitely, it's going to attract positive ions. And the positive ions will be called cations. And now the positive anode will attract negative ions, and the negative ions are called anions. I need you to write that down. The negative electrode, which is the cathode, will attract the positive ions. That means they could be metals and hydrogens. And these positive ions are called cations. Now, the positive electrode, which is the anode, will attract negative ions, and the negative ions are called anions. All right. Did you get that, please? Sorry, did you get that?
Yes.
Okay. Okay. Awesome. Now, um, okay. Remember I said something about electrolytic cell. What I showed you, that's what we call electrolytic cell. But for electrochemical cell, the reverse is the case. Okay, I think it's just nice I show you the electrochemical cell immediately. Okay, let's continue. We should be able to know the difference between electrolytic cell and electrochemical cell. That electrolytic cell converts electrical energy to chemical energy because current is required. But electrochemical cell converts chemical energy to electric energy. Okay, for electrolytic cell, cathode is a negative electrode, while the anode is a positive electrode. But for electrochemical cell, the cathode is the positive electrode, while the anode is the negative electrode. Very important. For electrolytic cell, we have what we call salt bridge. Salt bridge is not needed in electrolytic cell, but for electrochemical cell, salt bridge is required. Okay, now you're going to now let's talk about the principles of electrolysis. Principles of electrolysis. I'm going to show you a video after some of these things I'm saying, because I'll need you to get a comprehensive, when we have a comprehensive background into this, by the time we go into questions regarding electrolysis, we know how balanced we could be. Now let's look at the principles of electrolysis, cations and anions. Cations, okay, let's see, okay, cations and anions, very instructive. Now, remember, an electrolyte is composed of positive and negative ions. Remember, we said an electrolyte is a compound that can conduct electricity. Now, during electrolysis, electron move from the negative pole of the battery. During electrolysis, oh, I think I really need to share this out. This is a principle of electrolysis. Okay, I just did now. Okay. Okay, now, during electrolysis, electrons move from the negative pole of the battery to the cathode. During electrolysis, electrons move from the negative pole of the battery to the cathode, making it to be electron rich and negatively charged. That's why we call the cathode the negative electrode. Why? Because electron moved from the negative pole of the battery to the cathode. Remember, electrons flows from the negative to the positive. So from the negative end of the battery, it flows to the cathode, making it rich in electrons and negatively charged. Now, positive ions migrate. Positive ions that migrate because of its because the cathode is already electron rich. What happens to ions? Ions, positive ions, migrate naturally towards the cathode, and therefore they are called cations. Now, the anode becomes poor in electrons from the battery, and because of that, they become positively charged. Hence, negatively charged ions migrate to the anode, and they are called anions. So this is very instructive because when I start writing at the cathode and I'm showing you some positive ions, you should be able to understand that, wow, I think I understand this now. It's because the negative electrode gets electrons from the negative end of the battery to the cathode and makes it rich in electrons. Naturally, positively charged ions will flow to the cathode. Remember, there's a difference between ions and electrons. Ions and electrons. Okay? So when this happens, the positive ions goes to the cathode. Now, but the positive electrons, sorry, not positive electron, because the electrons are naturally negative. The anode becomes electron poor, and hence they become positively charged. We have more protons in there. Now, what happens to that? It naturally attracts negatively charged ions like chlorine, like fluorine ion, hydroxide ion, and such like. And they become anions. Do you understand that, please? Oh, you are muted.
Yes, sir.
Okay, thank you. Now, let's look at factors affecting the discharge of ions. Oh, God. Now, let's look. Hello, can you hear me?
Yes.
Okay, let's look at factors affecting discharge of ions and product of electrolysis. Factors affecting the discharge of ions or the products of electrolysis. Okay, now during electrolysis, actually we have three major factors that affect discharge of ions, but during electrolysis, the ions in the electrolytes are positively and negatively charged. Now, the negatively charged ion, remember we said we migrate, the negatively charged ion will migrate to the negatively charged cathode. In order to know which of the ions we preferentially discharged, we need to know these factors. Some factors affect discharge of ions. Oh God. And one of such factors, very, very important. Have you heard of this thing called the Electrochemical Series?
Yes.
Okay, that means you know you have the Electrochemical Series. Do you have them?
Yes.
Oh, awesome, awesome. That's beautiful. Now, I have to see how to get this because we would be using this a lot. We'll be using this really, 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 really. Come on, let's see. Can we get this? Oh no, 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 no. Okay, let's see if we could get that written down. Okay, let's see a video first before we go into that example. Let's see a video first. I think it would make more sense there.
Hi, welcome back to freesciencelessons.co.uk. Ionic compounds can conduct electricity when molten or dissolved in water. You should then be able to describe the reactions taking place at the positive and negative electrodes during electrolysis. And finally, you should be able to describe the reactions as either reduction or oxidation. That's for higher tier students only.
Okay, at the end of this class, that's this video. Number one, you should be able to. I believe before you should be able to tell me what number one is. Explain why ionic compounds can conduct electricity when molten or dissolved in water. You should be able to. Can you say this? Can you give an idea before I continue with this?
Um,
Okay, no problem. Let's
because the ions
because the ions are what?
are freely dispersed. Like, they're
Are
not
what?
close
I only hear
together.
that word. Are what?
They are dispersed, like they are free moving.
Correct, correct. Because they are free moving. Remember, ionic compounds are they have to do with positive transfer of electrons. They are free moving. When they dissolve in water, what happens to them is that when they are molten or dissolved in water, they ionize, and that makes them to be free moving. And that's what that this fulfills one of the conditions of for electrolysis I started with by saying they must either be in molten form or dissolved in water. So when I said electrolysis of sodium chloride solution, I meant something, and you will discover it here. So let's watch this now.
Now, electrolysis can seem like quite a tricky topic, so I'm going to split this over several videos. I should point out it's not as tricky as it first appears. In this video, we'll explore the general ideas behind electrolysis, and in later videos, we're going to look at some specific examples which you need to learn. We're going to start by recapping ionic compounds. This is the ionic compound lead bromide. This is formed when lead reacts with bromine. When lead bromide forms, a lead atom loses 2 electrons like this, forming the lead ion Pb2+. These 2 electrons then pass on to 2 bromine atoms, forming 2 bromide ions Br- like this. Now we form the ionic compound PbBr2.
I hope you know what happened here.
Yes.
Okay.
So as you can see, lead bromide contains 2 different ions, the lead ion Pb2+ and the bromide ion Br-. So what happens when we carry out electrolysis on ionic compounds such as lead bromide? Let's start by looking at some key facts about electrolysis. Here's the first key fact. Solid ionic compounds cannot conduct electricity, and that's because the ions are locked in place. They're not free to move. I'm showing the structure of a solid ionic compound here. This is lead bromide, which we saw before, but the idea applies to all ionic compounds. As you can see, the ions are locked in a regular pattern. They're held in place by strong electrostatic forces of attraction, so the ions are not free to move. However, when an ionic compound is melted or dissolved in water, the forces of attraction are broken and the ions are free to move. Because the ions can now move, these liquids and solutions can now conduct electricity. And scientists call these liquids or solutions electrolytes. So we're going to look now at what happens when we carry out electrolysis on a molten ionic compound such as lead bromide. Remember that the word molten means melted. So lead bromide contains 2 ions, the positive lead ion Pb2+, and the negative bromide ion Br-. In electrolysis, we've got 2 electrodes. These are made of a conducting material such as graphite or a metal. The negative electrode is called the cathode. That's attached to the negative terminal of a power pack. Think of the cathode as being covered with electrons which are coming from the power pack. The positive electrode is called the anode. That's connected to the positive terminal of the power pack. Think of the anode as having a lack of electrons. Here's our molten lead bromide. We can see the positive lead ions here, and we can see the negative bromide ions here. The positive lead ions are attracted to the negative electrode, and that's because opposite charges attract. The lead ions now gain 2 electrons to form lead atoms. Because the lead ions are gaining electrons, that's an example of a reduction reaction. The negative bromide ions are attracted to the positive electrode. Here they lose 1 electron to form bromine atoms. Because the bromide ions are losing an electron, that's an example of an oxidation reaction. Now I should point out that bromine atoms pair to form a bromine molecule, so we usually show the reaction like this. In the next video, we're going to look at how we can use electrolysis to extract reactive metals such as aluminium. Remember, you'll find plenty of questions on electrolysis in my revision workbook, and you can get that by clicking on the link above. Okay, Okay, so hopefully now you should be able to explain why ionic compounds can conduct electricity when molten or dissolved in water. You should then be able to describe the reactions taking place at the positive and negative electrodes during electrolysis. And finally, you should be able to describe the reactions as either reduction or oxidation. And that's the higher tier students only.
Okay, let's come back now. Can you hear me?
Yes.
Okay. Now let's come back to this. Now, we're going to look at now what they did was electrolysis of lead bromide. I hope you understood that.
Yes.
Okay. Now, for this, now we are going to be looking at electrolysis of sodium chloride solution. Now, when I said, now can you tell me the ions again? We said sodium ion, chlorine ion. Can you think of another ion that will be there?
H plus.
Sorry?
H plus.
What did you say?
Hydrogen ion.
Hydrogen ion. Awesome. How did you know it was hydrogen ion? What else again?
Hydroxide ion.
Hydroxide ion. Why did you say this? Tell me.
Because it is in solution.
Yes, it's a solution. That's exactly what I wanted to explain. So whenever we talk about solutions, whenever we talk about, we call a compound and we say this solution, whenever we say this, sodium hydroxide solution or sodium chloride solution, whenever we declare this, when we say okay, whenever we say sodium chloride solution, sodium chloride is mixed with, that sodium chloride is mixed with water. So that means all the ions we will have together will be sodium ion, chlorine ion, hydrogen ion, and hydroxide ion. That's awesome. Okay, from here now, how do we draw a diagram? A diagram would be something like this. Okay. Now these are the electrodes. Okay, I can call this the negative electrode. I can call this the positive electrode. Now we know definitely uh, this is water. Now now tell me, if this is the negative electrode, this is the cathode. Among those ions we've mentioned, you know definitely that the positive ions will be attracted to the negative electrode. So what are the positive ions? We have sodium, 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 not just that, hydrogen, hydrogen, hydrogen. Okay, now chlorine. Now, okay, now this is exactly what happens. Now this is exactly what happens. Sodium, now this is what happens. Sodium ions The sodium ions and hydrogen ions get attracted to the cathode. This is the cathode, while hydroxide ion and chlorine ion get attracted to the anode. Okay, so with this now, we are expected to write out the reactions that happen, what happens now at the cathode. What happens at the cathode? Now, this is exactly what happens. Remember, we said at the cathode, what happens at the cathode? Both Na ion, that's sodium ion, and hydroxide ion migrates to the cathode, where hydrogen ions. Now, can you tell me now, with these things we've discussed, remember we said at the cathode, what flows to the cathode? Sodium and hydrogen ion, right? Okay. What flows to the cathode?
No,
Sorry, what did you say?
hydroxide and
No, not hydroxide, hydrogen. At the cathode, what flows to the cathode? Or which ion flows to the cathode?
okay, so
Sorry?
sodium and hydrogen.
Sodium and hydrogen ion.
Sodium and hydrogen ion.
Now, can you tell me which ion will be discharged preferentially at the cathode? According to what we discussed now, can you tell me which ion will be discharged preferentially? That's based on the position.
Hydrogen ion.
Yes, hydrogen ion will be discharged preferentially. Why? Because hydrogen is lower than sodium in the electrochemical series. Therefore, sodium ions would remain in the electrochemical series. Now, we're expected not just to tell us, we're expected not just to know which ions will be preferentially discharged, we are expected to write what we call the half reaction at the cathode. That's the cathodic half reaction. I'm sorry, did I say that? No. We are expected to write what happens at the cathode, the kind of reaction that happens at the cathode. Now, at the cathode, since we know definitely that hydrogen will be discharged at the cathode, and remember, we have hydrogen ions. Remember, this is already a hydrogen ion. Now, what happens if this is a hydrogen ion already? What happens? It gains electron to become an hydrogen atom. Now, we know definitely, now it gains, this is hydrogen ion gaining an electron. Remember, this is +1 plus -1, that gives you 0. But we know definitely that hydrogen cannot exist. One of the properties of hydrogen is that hydrogen is diatomic. Hydrogen cannot exist just like that as an atom. Rather, hydrogen exists as a gas because of its diatomic property. So that becomes hydrogen plus another hydrogen. That's a covalent bond, giving you hydrogen gas, that's H2. So this is exactly what happens at the cathode. The hydrogen will be discharged preferentially. Okay, having known this, do you understand this, please?
Yes.
Okay, now let's go to the anode. We've considered the cathode. What are the ions that will migrate to the anode? Sorry?
Hydroxide and chlorine ions.
Good. Hydroxide and chlorine.
Hydroxide and chlorine ions.
Okay. Which ion will be discharged at the anode?
Chlorine.
Sorry? Which hydroxide will be discharged at the
Hydroxide.
anode? You said?
Hydroxide.
Hydroxide. Why? Because chlorine is higher than hydroxide in the electrochemical series. So because of that, hydroxide ion will be discharged. Now, how do we represent that? Remember, this is hydroxide ion. What happens to this is it's already losing an electron, so that becomes OH. Okay, that becomes the OH plus. Okay, welcome. Now, at the cathode, at the anode, hydroxide ion is discharged. Now, hydroxide ion is discharged at the anode. Now, because of that, we have hydroxide reacting with hydroxide. Hydroxide reacting with hydroxide to give us hydroxide reacting with hydroxide to give us oxygen. That's what we have here. Oxygen gas is released, therefore, at the anode. Now, this is just an example of this is just what happens at the anode. Now, we're going to be looking at the overall reaction. We're going to be looking at the overall reaction from here. This is not all that happens at the anode. What happens at the anode from here, it's okay, I'm coming. Okay. Okay, this is what happens at the cathode, and this is what happens at the anode. Now, this is the overall reaction. This is the overall reaction. Now, one of the things we should understand is that electrolysis of sodium chloride solution is also called brine solution. Now, when they ask you to do electrolysis of brine solution, it's actually electrolysis of sodium chloride solution. Hello, can you hear me? Now, what I was trying to say is that electrolysis of sodium chloride, electrolysis of brine solution is the same thing as sodium chloride solution. Now, one of the things we understood is that at the cathode, one of the things why I ask you is state what is released at the cathode and state what is released at the anode. Now, what is released at the cathode is hydrogen gas, and what is released at the anode is oxygen gas. Now, what remains in the solution? What remained in the solution? Can you tell me what remained in the electrolyte? Sorry. What remained in the electrolyte? What remained in the electrolyte for the cathode was sodium, and what remained in the anode was what? Chlorine. So why I could actually ask you to draw that diagram which I've drawn. Number one, they would also ask you to okay, like what I said is that White is going to ask you the electrolysis of this compound. Number one, you have to draw it. Number two is that you have to tell us what will be released at the cathode and what will be released at the anode. You must be able to write the half reaction. That's the half reaction at the cathode, the half reaction at the anode, and she'll be able to give us the overall reaction, number 2, number 3. Now, the next thing she'll be able to do is she'll be able to tell us what remained in the solution, in the electrolyte. So, from what we have done, we understood that sodium remained in the electrolyte at the cathode, and chlorine ions remained in the electrolyte at the anode. So that gave us that we still had sodium chloride solution remaining, while hydrogen and hydrogen will be released at the cathode, and hydrogen and oxygen will be released at the anode. I hope you got that, please. So that becomes the product of electrolysis.
Yes.
Okay, so that means that the effect of electrolyte on that electrolysis is that at the end of the electrolysis, the electrolyte will be more concentrated, since OH minus hydroxide ion and hydrogen ion have been removed. So what will happen is that the effect of the electrolyte on the electrolysis is that the electrolytes will be more concentrated with sodium chloride solution. Do you understand that, please? Do you understand that, please?
Yes.
Okay, thank you very much. Now, what we've just done, what we spent
Yes.
time doing today is effects of position of ions in the electrochemical series. We would advance quickly. We might just be able to treat 2 factors today. Probably next time we would continue with the other factor, which is the nature of the electrode. But today, let's continue with concentrations of ion in the electrolyte. Number 2, remember we're talking about factors that affect discharge of ions or the product of electrolysis. We have looked at we've looked at their position in the electrochemical series. Now let's look at number 2, concentration of ion in the electrolyte. Concentration of ions in the electrolytes. Concentration of ions in the electrolyte. Okay. Now, one of the things we must get to understand is that increasing the concentration of a given ion tends to promote discharge from a solution. Now, the influence of concentration, however, is effective when we have 2 competing ions. Now, when you have two competing ions that are closely positioned in the electrochemical series, when we have 2 ions that are closely positioned in the electrochemical series, now the effect of concentration become less as the positions are far apart. What am I trying to say? Now, this is, for example, when 2 ions are closely positioned in the electrochemical series, what will happen? One of the things that will happen is that the effect of concentration will be more effective. If they are closely positioned, that means concentration will have a full course in that electrolysis for the cathode and the anode. Oh God, what's this? Okay, can you hear me now, please? Hello, are you there?
Yes, sir.
Okay. I said something. I said something very instructive, that the influence of concentration is very effective when 2 competing ions are closely positioned in the electrochemical series. The effect of concentration is effective, very effective, when 2 ions are closely positioned in the electrochemical series. However, But what if they are far apart? Then concentration becomes less important. If they are far apart, concentration becomes less important. Now, let's take this for example. We are going to take the same question which we used, but this is going to be more. This is going to be more. For example, let's look at e.g. example, electrolysis of concentrated sodium chloride. Remember, what we looked at was just concentration of sodium, electrolysis of sodium chloride. But now we want to look at electrolysis of concentrated conc sodium chloride. This is a strong sodium chloride using graphite electrode. Remember, these are electrodes that do not tamper with electrolysis. So let's look at this. Electrolysis of concentrated sodium chloride using inert electrode. Using inert electrode. Now, this is conc NaCl. Now, I need you to tell me what will be released at the cathode. I need you to tell me what will be the cations and what will be the anions. Just tell me that, please. Okay, what will be the cations and what will be the anions for that solution? Electrolysis of conc sodium chloride solution. What is it? So tell me, what will be the cations and what will be the anions?
Na plus and H plus.
Okay, Na plus and H plus will
Yeah,
be cations, right? Okay, what will be the anion?
And Cl plus and OH minus.
Yes, Cl plus and OH minus. Now, this is where
so
we're talking
Cl
about
minus and OH minus.
Sorry?
Cl minus.
Okay, now this is a Cl minus, that's chlorine ion and hydroxide ion. Now, this is what happens. Now, let's start with the cathode. Now, remember, sodium and hydrogen will migrate to the cathode. Now, with what I told you, I don't know if you wrote what I said about concentration, that the influence of concentration will be stronger if the ions are closely positioned in the electrochemical series. And the effect of concentration will be less if it is what? The effect of concentration will be less if they are far apart. So with this understanding, I need you to go check the cathode. At the cathode, which one will be discharged?
Cl minus.
At the cathode.
Sorry, okay, H plus and.
Sorry?
H plus ions are discharged at the cathode.
Please say that again, please.
Hydrogen ions are discharged.
Okay, hydrogen ions. Now, definitely, that's awesome. Hydrogen ions will be discharged. Why? Sodium ions are more in concentration, number one. Number two, the distance between sodium and hydrogen is very far. Look at where sodium is. Sodium is at about number 2 in the electrochemical series. And look at where hydrogen is in the electrochemical series. We have from sodium 1, 2, 3, 4, 5, 6, 7 is quite a distance from the electrochemical series from sodium. The electrochemical series from sodium. So because of that, hydrogen will be discharged. Effect of concentration. Now, but let's go to the anode. Let's go to the anode. What will be discharged at the anode? What will be discharged at the anode?
At the anode, chlorine ions actually.
Why? Why will chlorine ion be discharged at the anode?
Because of the close position of OH ions
Sorry?
and Cl ions in the series. Because of the close position of chlorine ions and
Thank
hydrogen
you very
ions in
much.
the
Because of
series.
the close position of chlorine ion and hydroxide ion. So you see where effect of concentration is affecting. I mean, see what is happening there now. That okay, let's get this. Now at the anode, chlorine and hydrogen hydroxide ion, we migrate to the anode. Now chlorine ions is closely positioned with hydroxide ion, and because of that, chlorine ion will be released. So at the cathode, hydrogen gas is released. That's the product of the electrolysis. And at the anode, we have chlorine gas. Now, tell me what remains, what remained in the solution? What will happen to the solution? Tell me about the solution. So what are the ions that remains in the solution?
Sodium ions and hydrogen ions.
Sodium ion and hydroxide ion. And what does that tell you about the solution? What kind of solution is that?
Basic.
Sodium hydroxide solution. What kind of solution is that?
Basic.
Sorry?
Basic.
You're saying something. Come say it now. What kind of solution is sodium
Basic
hydroxide?
solution.
Okay. What kind of solution is sodium hydroxide? I'm going to help you. Is it an acid, base, or salt? Okay, basic, awesome. So what happens is that it's an alkaline solution. So that means that at the end of the electrolysis, what happens at the end of the electrolysis, the electrolytes will become alkaline because hydrogen ion has been removed, chlorine ion has been removed. That makes the solution, or that makes the electrolyte alkaline. So do you understand those two things I said? Number one, effect of position of ions in the electrochemical series. Number two, effects of concentration of ions. Effect of concentration of ions. And the next time we'll be looking at the effects of the nature of electrode. Okay, but before I leave you, I'm going to give you questions to solve. Okay, number one question I want you to look at is explain the electrolysis of acidified water. Explain the electrolysis. Yeah, the first question is explain the electrolysis of acidified water. When I mean explain the electrolysis, I mean you should tell me, number one, what happens at the, you should list the ion, the anions, the cations. You should tell me what happens at the cathode, what happens at the anode, the products of the electrolysis, and what happens to the electrolytes after electrolysis. So these are the things, these are the major things I need in that question. All right. Okay. Now, number two, electrolysis of copper 2 tetraoxosulfate 6. Electrolysis of copper 2 tetraoxosulfate 6 using graphite electrode. Electrolysis of copper 2 tetraoxosulfate 6 solution. Sorry, I did not add solution. Electrolysis of copper 2 tetraoxosulfate 6 solution using graphite electrode. And number three, it's electrolysis of copper 2 chloride. Electrolysis of copper 2 chloride using platinum. Electrolysis of copper 2 chloride solution. Electrolysis of copper 2 chloride solution using platinum electrode. Using platinum electrodes. Okay, so remember the first one is acidified water. Acidified water will be using platinum electrode. We'll be using the inert electrode. The second one is copper 2 tetraoxosulfate 6 solution using graphite electrode. And the last one is electrolysis of copper 2 chloride solution using platinum electrode. Now, these are the things I need. Number one, you're going to draw the diagram. Number two, you're going to list the cations and the anions. Number three, you write the reactions at the cathode, the reaction at the anode. You tell me the products of the electrolysis and the things that will be remaining that's in the electrolyte, and you tell me the effect, what happens to the electrolyte? What kind of solution will be in the electrolyte? Will it be more acidic? Will it be more basic? Do you understand this point?
Yes.
All right. Any question, please?
No.
Okay. So the next time we'll be looking at the effect of the nature of electrode. Wow. All right. Let's pray. Father, we thank you. Thank you for how far you've helped us. Blessed be God forevermore. In Jesus' name. Amen. All right. Have a wonderful time. Bye.